Hello students, welcome to Sciacademy. Hope you all are good and doing well and learning the physics. In the today's video lecture, we will be talking about the refraction at spherical surfaces and refraction by the lenses. So students, we have learnt so far refraction at a plane interface, and we have discussed about the different properties of the light during refraction, and also learnt about the total internal reflection and its applications in daily life. So students, we shall now consider refraction at a spherical interface between two transparent media. Students, you know that an infinitesimal part of a spherical surface can be regarded as a planar. That means if this is spherical surface or curved surface, we can every small part of this surface regard as a planar surface for the laws of physics related to light to be applied. Just as for reflection by a spherical mirror, the normal at the point of incidence is perpendicular to the tangent plane to the spherical surface at that point. So normal, what will be, how we can draw a normal to the spherical surface? So for drawing normal at any point of incidence, we will draw perpendicular to tangent. Suppose this is a tangent, so normal will be perpendicular to this tangent. So we first consider refraction by a single spherical surface and then follow it by the thin lenses. That is, first we will learn about the refraction by a single spherical surface, then we will combine it for the lenses. A thin lens is a transparent optical medium. So what is a lens? We are talking here about a thin lens. That is a transparent optical medium bounded by two curved surfaces, at least one of which should be spherical. So it is not necessary that the lens will be having the both surfaces as a curved surfaces. Lens can be like this also. One surface may be plane, another surface may be curved, or one surface may be plane and other surface may be curved, or this also, one surface may be plane and other surface may be like this, and lens also will be like this or will be like this. So we'll be discussing all those type of lenses, applying the formula for image formation by a single spherical surface successfully at the two surfaces of a lens. We shall obtain the lens formula. Now we'll take refraction at a spherical surface. In figure 9.17, you can see that this is a spherical surface, and C is the center of curvature, R is the radius of curvature, and N1 is the refractive index of this medium, and N2 is the refractive index of the curved surface, spherical surface. Now we'll take the geometry of formation of image I of an object O placed on the principal axis. So this is the principal axis of the spherical surface. The rays are incident from a medium 1 to medium 2. Since we want to make angle of incidence as small as possible, That's why we'll consider the aperture of this spherical surface to be as small as possible, and in that case, this enum will be treated as the normal to this principal axis. So, enum will be taken to be normal equal to the length of the perpendicular from the point N on the principal axis. For small angles, tan theta is equal to mn by om. Here tan theta, that means angle NOA. This angle will be given by this length of perpendicular mn divided by om. Here this distance is ignored as we are considering the angle, as we are considering the aperture is very small, so that it will be negligible. And tan angle NCM mn divided by mc, and tan NIM, that is this triangle, mn by mi. So for triangle NOC, I is the exterior, therefore angle I is equal to angle NOM plus NCM. See, this angle I is equal to this angle. For this triangle NOC, this I is the exterior angle, and this is equal to the summation of this angle and this angle. Therefore, for this we can write I is equal to angle NOM plus angle NCM, and that is equal to I is equal to, since tan of angle NOM is equal to MN by OM, and we are applying tan theta is equal to theta for small aperture. Therefore, this angle NOM is equal to MN by OM. Similarly, we can write for this tan angle NCM is equal to NCM, tan angle NCM is equal to MN by MC. So using these two relation, we have I is equal to Mn by Om plus Mn by Mc. Similarly, we can write for the angle of refraction R, that will be given by angle NCM minus angle NIM. Since this triangle, this is the exterior angle for this triangle, and therefore this angle NCM is equal to angle R plus angle NIM. Therefore implies that R is equal to angle NCM minus angle NIM. So we will use this relation here, and hence angle R is equal to Mn by Mc minus Mn by Mi by applying the principle of tan theta is equal to theta for the small aperture. Now by Snell's law, we know that N1 sin I is equal to N2 sin R, where N1 and N2 are the refractive indices for the two media, and for a small angle sin I is equal to I and sin R is equal to R. Therefore, N1I is equal to N2R. Now, we will substitute the value of angle I and angle R in this relation from equation 9.13 and equation 9.14. So let's put these values. So we'll have N1 I means Mn divided by Om plus Mn divided by Mc is equal to N2 R means Mn divided by Mc minus Mn divided by Mi. Arranging this, we get N1 Mn by Om plus N1 Mn by Mc is equal to N2 Mn by Mc minus N2 Mn by Mi. Therefore, N1 by Om plus N1 by Mc is equal to N2 by Mc minus N2 by Mi. Now N1 by Om plus N2 by Mi is equal to N2 minus N1 by Mc. That means we get this value N1 by Om plus N2 by Mi is equal to N2 minus N1 divided by Mc. So this is the equation for the magnitudes of distances. Now we will apply the sign convention in the Cartesian system. So OM is the distance of object from the spherical surface that is in the direction opposite to the direction of the incident ray. That's why it is negative, that is minus u. And Mi is the distance of image from the spherical surface and it is in the direction of the incidence ray. That's why it is positive, and MC is the radius of curvature, that is also positive. Substituting this sign convention, we get N1 by minus U plus N2 by V is equal to N2 minus N1 by MC, that is R. Therefore, we get this N2 by V minus N1 by U is equal to N2 minus N1 by R. And this is a relation between object and image distance in terms of refractive index of the medium and the radius of and the radius of curvature of the curved spherical surface. And it is true for any curved spherical surface. This is the very important relationship which we derived N2 by V minus N1 by U is equal to N2 minus N1 by R. So please remember this relation. It will be useful for solving the numerical problems based on the refraction due to the spherical surfaces. Students, now let us solve this example 9.6. So in this question, it is given that light from a point source in air falls on a spherical glass surface with refractive index 1.5 and radius of curvature is given as 20 centimeter. The distance of the light source from the glass surface is 100 centimeter. So find the position of the image formed. So basically, we are given the distance of the object from the spherical glass surface. Suppose this is a spherical glass, and this is the principal axis, and the object is here at a distance u is equal to minus 100 centimeter, and radius of curvature is equal to 20 centimeter. If see this is the center of curvature, then this will be this distance is given r, that is plus 20 centimeter. And refractive index for the air is N1 is equal to 1 and refractive index for the glass surface is given 1.5. Now you are given U is equal to minus 100 centimeter, R is equal to 20 centimeter, and N1 and N2. So using the relationship N2 by V plus N1 by U is equal to N2 minus N1 by R. So use this relationship just we derived and you will get N2 1.5 divided by V minus minus plus 100 1 by 100 is equal to N2 minus N1 is equal to 0.5 by R. So solving this, let us solve this. 1.5 V is equal to 0.5 by 20 minus 1 by 100. So 5 by 200 minus 1 by 100 is equal to 200, 5 minus 2, that is equal to 3 by 200. So V is equal to 200 divided by 3 into 1.5, that is equal to 300 by 3. So we get 100. Right. So students, I hope you enjoyed this video lecture and learned about these topics refraction by the spherical surface. If you have not subscribed the Sciacademy channel, please subscribe just now so that you can get the upcoming videos notification on time. And please like the video and share with your friends so that they can also learn about this topic. Students, if you have any doubt, query, please let us know by providing your comments. You can also follow us on our social media platform, Facebook page, Sciacademy, our Telegram channel, or you can also follow us on the Instagram. So students, let's meet in the next video lecture. We will cover in the next video refraction by a lens, power of a lens, and combination of thin lenses in contact. And we will also solve some basic problems based on these principles of lens. So we will cover all these topics in the next videos. So students, please stay tuned and subscribe the Sai Academy channel and share this video lecture with your friends and family members, and also ask them to join the Sai Academy family so that they can enjoy the free video lecture on the physics topics. We will cover all the syllabus of your 12th and 11th classes one by one. So please stay tuned and thank you.